Hello guys, today we're doing LeetCode question 322, coin change. Question is medium and it is, you are given an integer array coins representing coins of different denominations and an integer amount representing a total amount of money. Return the fewest number of coins that you need to make up that amount. If that amount of money cannot be made up by any combination of the coins, return -1. You may assume that you have an infinite number of each kind of coin. So example 1, the coins is an array of 1, 2, 5. So these are the types of coins you have. And the amount is 11, so we have to get the shortest amount to get to 11. So the explanation, the output is 3 and the explanation is 11 is equal to 5 plus 5 plus 1, which is the shortest way to get to 11. Now example 2, coins is 2, the amount is 3, and the output is -1 because you can't get to 3 multiples of 2. 2 gets a 2, and then plus another 2 as it's our only coin gets a 4, so we don't get a 3, return -1. So the way we'll do this is by pretty much storing an array here, as you can see, which is the amount, the length with a length of amount plus 1. The reason is we're going to count for each, we're going to set each value to infinite, and for each value we set the minimum it takes to get to that point. So I'll walk you through it. So for example, we set the first value as 0, the rest here will be infinite. So let's write a line here to represent infinite. So the blue is infinite amount, for now anyway. So we do a for loop to loop through first each value in the array. And then we loop through each coin as a nested loop. So the first thing we check is we start from array position 1. So we're here. Now we check, we have coins 1, 2, and 5. So we loop through the first coin, which is 1. We check, how do we get to 1? By checking the position -1 plus 1. So the position -1 is 0. So to get to 1, is 0 plus 1, which equals a 1. One move, so we set 1. You loop for the next one, we go through 2. To get to position 1, we do 2 minus the current position -2, which is out of bounds, so we skip that. 5 is the same, out of bounds, so we skip that. So we go to the next array, next value, which is now here. So we start from 1. 1 minus 1 is 1 here. So position -1 is 1. So we add 1 to get to that step. So now that is a value of 2. 2 ones gets to that step is 2. Now we go to 2. We're at position 2 here in the coins array, sorry. So to get to 2, we check the current position -2, which is 0. So we know that from 0 to 2, with 2 is just one step. So we remove the 2 and set to the minimum. We can get to 2 with one jump of 2. We go to the next value, which is 5. But of course, position -5 is out of bounds, so we continue. Now we're in the third position in the array, or the fourth position anyway. And so we check for 1. 1, so the position -1 is 2. 2 plus 1 is now 3. Then we get a second coin, 2. We go back 2 steps, 1. 1 plus 2 is 3, so it remains 3. And then 5 again is out of bounds. So we're here, so we want to do that. So then we go to the next value here, next position. So this is position of 4. So we do again, we check 1. Position -1 is 3, so to add 1 is another step. Now that's 4. Then we do the same for 2. We go that back 2 steps, 2 steps. If we get to the position by adding 2, so the current value 2 steps behind is 2. 2 plus 1 is 3. We get to that in 3 steps. Oh, sorry, I forgot to mention. This is not 2. This is 1. I made a mistake here. We get to that in 1 step with 2. And now, to get from here to here, just use 2 again. So that's 1 step. We add it. And now that's 2. And again, if we go back 5, it will be out of bounds. So we go to the next position. Now we check 1. We move back 1 step, which is 2. So to get to that spot is 2 plus 1. Current minimum is now 1. Sorry, not 1. 3, because 2 plus 1 is 3. We go to the next value in the coins array. We're at 2. We go back 2 steps. Now 3 plus 1 is 4. So we don't change it because our minimum is still 3. We go to 5. Now finally we can use 5. We jump back 5 steps. To get from 0 to 5 in jumps of 5 is just 1. So our minimum to get to that spot is 1. Then we go to the next position in the array. So we're at 6. So we check current position minus 1. The minimum to get there is 1. So we add 1 to this position. The current coin is 1. So the minimum is 2 here right now. Do the same for 2. Current position 2 plus 1 is 3. So the minimum is still 2. Go back 5. 1 plus 1 is 2. So again, minimum remains 2. Go to the next value in the array. Now here. So we go back by 1. That's our first coin. 2 plus 1, 3. We go back by 2. Oh, we can see that now it's smaller. 1 plus 2 is 2. So we can get there 2 jumps. That's 2. Then go back by 5. Again, it's 2. So we leave it as that minimum. Then we go to the next value in the array. And we check. Go back by 1. So we go to that step, the minimum 2 steps. We add 1 for the current coin. So that's 3. We go back 2 steps. We add, minimum to get there was 2. So we add a 1. So the minimum again is still 3, remains 3. Go back 5 steps. 3 plus 1 is 4, so we don't change that, as that is bigger than our current minimum. We go to the next position. Now we go back by 1. We see that our previous shortest time to get there is with 3 moves. So now we have 4. Go back by 2. Now we see, oh, 2 plus 1 is 3. So now our shortest time to get there is with 3 coins. Then we go back by 5. You can see 2 plus 3 again. 2 plus 1 is 3, so we leave it as 3 as our minimum. Go to the next spot. And then we go back by 1. Our shortest for now is 4. Go back 2, that remains 4. Go back 5. Oh, we see to get to 5 is 1 coin, plus another 5 is 2. So now our minimum is 2. Select these. And our final step, we're now here, go back by 1, so it's 3, go back by 2, 3 plus 1 is 4, so that remains 3, we go back by 5, and 2 plus 1 is 3, so we leave it as 3. We return our final value of the array. But as mentioned, if we don't get the array, we can't return the final value, because it doesn't fit. What I mean is, for example, if it was 1, 2, 3, and we have a coin of 2. So we jump 1 from here, 0, go here, 2, and we can never get here because we have another coin which takes us to 4. So in this case, this will still be infinite. So we check with base case at the end. Well, if statements were not base case. If the last value in the array, so array length is equal to infinite, then we return -1. Otherwise, we return the last value in the array. So that's how we solve this problem. Let me show you how to do this in code. So first thing we do again is we create an array. So let array is equal to new array with a length of amount plus 1. We have to store 0 as our first value, and then the rest is just the length of the amount. And then we fill it with infinity. So everything that we input will be less than that. Then we set our first value, as mentioned, to 0. So array 0 is equal to 0. Now we loop through our amount first, through our array. So for let I is equal to 0, is I smaller than array length. Oh, we start from 1, sorry. The first position is 0, we don't actually count that. Then we increment. Then we loop through our coins array. So for let, I should do coin of coins. Okay, now we remember. So we have to check that the value, current position minus the value is inbound. So if the I minus coin is smaller, smaller than 0, then we know it's out of bounds. So we just continue to the next iteration of the loop. Otherwise, set the current array value, so array I, to the minimum of its current value, so again array I, or the position, so we'll do array I minus coin, which is the previous position, the minimum of that plus 1. Plus 1, because we know that we can get to the previous position by constructing the current coin. So the minimum of that plus the current coin is equal to our minimum steps to get to the current position. And each time we iterate through the array, we then check the minimum and set it to the minimum. And then we check if the array, so the last value in the array.length minus 1, we could also do the amount here, but let's just array.length minus 1, is equal to infinity. Then we return minus 1. Else, we just return, again, the last value in the array. Now let's see if this passes. It does. Let's submit. Perfect. As you can see, this beats most people for time complexity and most people for space complexity as well. Okay, so our space complexity is M of n, so M representing the coins, so the length of the array of the coins, and n representing the amount, because we loop through the length of the amount and through the length of coins. And our space complexity is just the length of the coins, sorry, length of the amount, because we store the array of length amount plus 1. Thanks for watching.